Hi everyone, this is Aarohi, and in this video I'll talk about another object detection algorithm, which is single shot detector. In my previous video I have already explained you YOLO algorithm and faster RCNN algorithm, which are also object detection algorithms. So link is given in description section in case anyone wants to go through those videos. So let's start with single shot detector. So I have just told you that SSD is used for object detection, and object detection means it will predict which object is present in image with their location. So let's understand the layer architecture of single shot detector. So this is the layer architecture. Over here you can see this is the input image, and we are giving this input image to VGG16 network first of all. So see, the SSD network starts with a VGG16 model. We are using this VGG16 at initial step to just extract feature maps. So guys, if you have gone through my faster RCNN video, so over there also we were using VGG16 network, right, to extract feature map. So in the same way we are extracting feature map over here also in single shot detector in SSD using VGG16. Right? So see, SSD makes many predictions for every single class, right? So basically what I'm trying to say over here is that these six layers are six convolutional layers which will perform the classification object detection task, and in SSD makes 8732 predictions for every single object. Right? That simply means for every object SSD will predict 8732 bounding boxes. And over here, right? So over here, this object detection, over here we will get 8732 bounding boxes for each object, right? So now see, as I've just told you, like these are lots of images, lots of boxes per object, right? So then we are using non-make suppression. Why we are using this non-make suppression over here? Just to remove the duplicate predictions. Basically what SSD will do over here, SSD will check the confidence score of each box and will pick the top 200 predictions per image, per basically per image it will pick 200 predictions, right? And see, this is the basic architecture of it. Now I'll explain you the things in more deeper way. Over here let's talk about training of SSD, how to train SSD. See, okay, and look at this image over here. So this is an image. Whenever you want to give input to single shot detector, the thing is like you should have images with ground truth boxes for each object in the image. So we have two objects in the image, and these two images are with ground truth boxes. So this is a requirement whenever you want to give data to SSD, that data, the input to SSD should be with these ground truth boxes, right? And then we are having convolutional layers, right, as I've just shown you in this picture. And then we are having convolutional layers. The task of those convolutional layers are to check boxes of different aspect ratios at each location in with different scales. Okay, so basically what we are doing over here, see, you can see in this image, this is an image with ground truth boxes, green color ground truth box is there for mobile, and orange color ground truth box we have designed for this laptop. But apart from these two ground truth boxes, we are having boxes over here, right? So basically what is happening over here, basically the convolutional layers will check the boxes of different aspect ratios. These boxes, if you'll see these big boxes are of different sizes and are of different aspect ratios, right? So these multiple boxes are of different sizes and aspect ratios, and we are saying multiple boxes. But how many multiple boxes? As I'm continuously saying, like convolutional layers will check multiple boxes, right? But how many multiple boxes? So 8732 boxes per object, as I've just shown you over here, as I've just told you over here, like at this object detection task, SSD will predict how many bounding boxes? 8732 bounding boxes per object, right? So I'm talking about that over here. So on this input image, the image with the ground truth boxes, on this particular image, so we have two objects over here. So that means for mobile we are going to have 8732 boxes, and for laptop also we are going to have 8732 boxes. So means SSD will tile 8732 boxes of different size and aspect ratio for each object. So see, SSD is using so many boxes over here, right? Why SSD is using so many boxes? It is simply for better coverage of location. Alright, so this process will help us finding the box that overlap the ground truth bounding box. So basically, why we are tiling these many bounding box on the image? Just because we want to find the box which have highest overlap over the ground truth box. Let me show you in the next image. So we are having so many boxes. So if you'll see this maroon box over here, right? Let me show you in next picture over here. The bounding box, this maroon box, this is having the highest overlap. So what we are doing over here, we are using IOU, intersection over union, and with the help of IOU we are finding a box which is having the highest overlap, and we will be finaling this as a output out of those 8732 boxes. Alright, so now let's talk about the matching strategy. Okay guys, give me a minute. Yeah, now let's talk about the matching strategy, how SSD match the boxes and how it gives us prediction. So basically, while training, SSD match the default bounding boxes. What are the default bounding boxes over here? The boxes, those 8732 bounding boxes per object, right? Those are the default bounding boxes. SSD will match those boxes with the ground truth boxes. And for this matching task, we will use IOU, intersection over union, and this overlap should be greater than 50%, right? And finally, we will pick those predicted boxes which have maximum overlap with the ground truth boxes, right? So this is the concept of SSD, right? Single shot detector. How it is detecting object? It is detecting object by tiling the default bounding boxes, and we are going to have 8732 bounding boxes per object, and then finally it will pick the top 200 boxes. All right, out of those 8732 boxes, it will pick the top 200 boxes, and then it will perform norm expression on it, right? And then finally it will give us a result. So this is what this SSD is. So in my next video, I'll show you the practical implementation of SSD. So guys, if you like the video, please subscribe my channel. Thank you for watching.